In our last video, we left off with a huge problem. Our room's wires were hardwired to one specific type of bulb. The bulb glowed, the system worked, but it was really fragile, as changing the bulb could mean messing up with the stable household wirings. So, we naturally arrive at a question of how do you make this system flexible enough so that changing the bulb never disrupts the stable household wiring. One might say we could use a better quality of bulb and wires both, but will it solve for our problem? Suppose we end up using better quality of bulbs and wires, but even if bulbs and wires improve their quality, they still need to be soldered. Like, we need to solder these wires and bulbs together for the bulb to glow. Now, since the bulbs and wires have improved their quality, the maintenance might be less, but changing a bulb is still not completely isolated from these wires. Because even if the chances of errors are really minor, still both wires and bulbs depend directly on each other because of the soldering. And there is no way we could replace this bulb in isolation. And actually, this direct dependency of bulbs and wires because of soldering, this is the pain point. Not the quality of wires and bulbs, but the direct connection, direct dependency of these bulbs and wires. There is a really simple solution to this problem, which you might already aware of. If the problem is this tight dependency between these two entities, how about if we make these two entities unaware of each other, or ignorant of each other, or I should say blissfully ignorant of each other? Here comes our middleman, the bulb holder. Think about it. The holder sits in between the bulb and the wires. The bulb does not need to know how the house is wired, and the wiring does not need to know what kind of bulb you will bring tomorrow. Essentially, what we have done is, prior to this, our movable part and stable system were directly connected. That is, the bulb and wires were directly connected. Now, both of these entities are connected to a middleman, that is the holder. They no longer know about the existence of each other. Now, the wires keep connected to the same middleman, and the movable part, which is the bulb, we can just replace it without affecting the wires, the wirings of house. But there is a catch. Yes, you cannot just fit any kind of bulb into this holder. The crucial thing is, this holder defines a common shape. If your bulb isn't compatible with this shape, you cannot fit into it. But as long as your bulb follows or is designed to fit into this, it will work. And it does not matter if it's LED, CFL, halogen bulb, any kind of smart bulb, or even if it's shaped like cylindrical cube. The only requirement is that connecting end of the bulb needs to be designed to fit into the holder. A bit more technically, what we can say is, this holder acts as an interface between the bulb and the wires, and it defines a contract that every bulb must follow. As long as bulbs design match this contract, we say bulbs implement this interface. That's why LED, CFL or smart bulbs can all work. Not because they are identical, they are not identical, but because they all respect the same contract, the contract that was asked by this holder. And now Whenever you change the bulb, if the bulbs follow the contract, the wires stay untouched, the bulb stays replaceable, and this simple yet effective ideas is foundational thinking for dependency inversion principle. So far we have seen the bulb analogy, in which we discussed the bulb, the wires, and the holder, which was acting like the contract. Now let us try to bring that same idea into programming. But before moving ahead, I'd like to urge you to pay close attention to the context whenever I use these terms. High level module, low level module, behavior, interface, contract, and implementation. Because understanding these terms would play a key role in understanding this whole concept. Now let us move ahead and picture a shopping app. We'll basically be discussing the payment part of it. When the customer checks out, the app has to calculate how much they need to pay, including the taxes, the discounts, the shipping charges, all of that. That calculation is done in our business logic. That is our high level module. This does not include processing payment. So calculation part of the payment is in our high level module. But once we are finished with this task, we know the amount. We then need someone to actually take the money from the customers. That's when our payment processor comes in, like Stripe, PayPal, Razorpay. These are our low level modules. Now let us look at two ways this whole scenario can play out. Case 1, direct dependency. Here the checkout section depends directly upon Stripe. It's like almost like soldering the wire straight onto the bulbs. This works, but this is rigid. If Stripe goes down, or the client suddenly says that, hey, I want to use PayPal instead, I don't use Stripe, I cannot pay using Stripe, we are stuck. We'd have to go back into the high level module and change the code and basically untangle the whole mess. So even a small change in the low level part focuses us to modify the high level part. So we can basically say that this checkout section at the mercy of Stripe, which basically means that this whole system is really rigid. This isn't flexible. Now let's look at this case 2. Here, instead of depending upon Stripe, the checkout depends upon a contract. And that contract only says one thing. Any provider, not just Stripe, any provider who wants to work here must be able to do one behavior, that is to process a payment. Contract, behavior, interfaces, these terms are often used interchangeably. They all point to the same idea. They are the high level overview of what must be done. Now, not how it's done, only what needs to be done. So the checkout depends on this contract. Stripe follows this contract. Payment follows this contract. And Razorpay follow this contract. Following the contract is basically the same as saying they implement this interface. Now the checkout doesn't care who's behind this contract. Providers can be swapped freely, and as long as they respect the contract, the checkout code never changes. And this is exactly like our bulb analogy. The checkout is the stable system, the wires, the payment providers, which are the low level modules, are could be looked as the bulb, and the contract, that's the socket, the holder. As long as everyone respects the socket shape, the system stayed flexible, testable, and future proof. And in this case too, if these providers obey this contract, they are easily swappable. The checkout does not directly depend on these low level modules.